All right, so we saw in the last video that there's this Pythagorean theorem that relates the sides of a right triangle. And the biggest thing we need to remember is that C in the formula always has to be the hypotenuse. It doesn't really matter A and B which is which, but C has to be the hypotenuse. And we wrote these down that C squared is equal to A squared plus B squared is equal to C squared minus A squared, and A squared is equal to C squared minus B squared. Okay, and we filled out this table to show us, or the table over here, to find that pattern. Okay, so here's what this theorem actually says to kind of recap. I'm going to take a look here at triangle 4. Okay, and the fourth triangle was a 2 by 2 triangle. So this, if we wanted to find the length of C, this is the hypotenuse, it's across from the right angle. What we would do is we would use this equation right here, okay? And that says that C squared is equal to A squared plus B squared. Okay, I'm going to call this one A and this one B, doesn't really matter. This one is C. So C squared is going to be equal to A squared, which is 2 squared, plus B squared, which is also 2 squared. Okay, so C squared is going to equal 2 squared is 4, and 2 squared is 4. Okay, so then we have C squared is equal to 8. Remember when we filled out our table, this one was 4, this square was 4, and this square was 8. Okay, well this side length was 2, this side length was 2 because it was the square root of 4, and this one was the square root of 4. Well, check this out. If we take the square root of C squared and the square root of 8, we get C is equal to the square root of 8. So this side length right here is actually the square root of 8. Okay? So we can use these equations to find missing sides. So we're going to look at several examples to kind of see in more detail how this works. All right, example A. First thing I like to do is label my sides with A, B, and C. The first one I always label is the hypotenuse. That has to be C. It's across from the right angle. So this is my C side. The other ones don't really matter. Okay? This could be A and B, or B, or A and B, or A and B. It doesn't really matter. I'm going to call this one A and this one B. I know, okay, my three formulas, actually I'm going to write them down. I know that C squared is equal to A squared plus B squared. So the big one is equal to adding the two smaller ones together. Okay, if I want to get B squared, that's equal to C squared minus A squared. So the big one minus the small one gives you the other small one. And then A squared is equal to C squared minus B squared. Okay, the big one minus this small one gives you the other small one. So I'm noticing here that I want to find B. So I am going to use B squared is equal to C squared minus A squared. All right? So now I'm going to plug stuff in. B squared is equal to C squared is going to be 17 squared minus A squared, which is 15 squared. And now I'm just going to do the math. B squared is equal to 17 squared is 289. 15 squared is 225. So B squared is equal to 289 minus 225 is 64. And now I need to solve this equation. Take the square root of both sides. So B is equal to 8. Now remember, it also equals negative 8, but a triangle can't have a side of negative 8. So B is equal to 8 centimeters. And then I just take a look. Does that make sense? Could this be 8? Yeah, it looks reasonable that that could be 8. All right, on to the next. Remember, we're going to start by labeling our sides. So across from the right angle is the C side. I'm going to call this one my A and this one my B. Now, I'm trying to find C, so I'm going to use C squared is equal to A squared plus B squared. All right, so then C squared is equal to, A is 8, so 8 squared plus 6 squared, because B is 6. C squared is equal to 64 plus 36. So C squared is equal to 100. And then I'm going to take the square root of both sides, and C is equal to 10. This one's measured in feet. So C is 10 feet. Does that make sense? Could this side be 10 if this one's 8 and this one's 6? Yep, looks reasonable. So C is equal to 10 feet. Okay, on this one, label my sides across from the right angle. That's my C side. I am going to call this one A and this one B. So I have, if I'm trying to find A, I'm going to say that A squared is equal to the big one, C squared, minus the other small one. So A squared is equal to C squared minus B squared. So then A squared is equal to 26 squared minus B squared, which is 24. So A squared is equal to 676 minus 576. A squared is equal to 100. Square root it. So A is equal to 10, and this one's measured in millimeters. Okay? If my hypotenuse is 26 and this one's 24, this one could be 10. That's reasonable. Okay, on to the next. Again, across from my right angle is my C side. I'm going to call 7 my A and X my B. So that means that B squared, that's the one I'm trying to find, is equal to the big one, C squared, minus the other small one, squared. So B squared is equal to, C squared is 9 squared minus, and then A is 7, so 7 squared. So B squared is equal to 81 minus 49. B squared is equal to 32. Square root it. Now, 32 is not a perfect square. So before we said we could leave it like this, but we actually want to have an approximation of what the side length of this triangle is. So I'm going to go ahead and use my calculator to figure that out. So 32, the square root, so let's think about it. I know the square root of 36 is 6, so I expect it to be close to 6, but not quite, between 5 and 6. So it tells me that it's approximately 5.7. I'm going to round it to 5.7 since it's 5.65. Okay? So B is approximately equal to 5.7. I use the squiggly equal sign to show that it's an approximation. And this one is measured in inches. Okay? 2 more examples. All right, across from the 90 degrees is my C side. I'm going to call this one A and this one B. Remember, it doesn't matter which is which. And I know if I'm looking for B, that's the side that's missing. I'm going to take the big one squared and subtract the smaller one squared. So B squared is equal to 14 squared minus 12 squared. So B squared is equal to 14 squared is 196 minus 12 squared is 144. So B squared is equal to 52. Square root both sides. So B is equal to, I already did this on my calculator and I figured out that the square root of 52 is approximately 7.3. And this one's measured in yards. Okay? I knew that it was between 7 and 8 because the square root of 52 is between 49, which is 7, and 64, which is 8. So I knew it should be close, or between 7 and 8, but I used my calculator to figure out that it was approximately 7.3. Okay, last one. This one, be careful on this one. This is my right angle. So that makes this side C. Kind of looks like this is the hypotenuse, but the C, the hypotenuse side, has to be across from the 90-degree angle. And then I'm going to call this side over here A and this side B. So I know that A squared is equal to the big one squared minus the other smaller one squared. So C squared minus B squared. So A squared is equal to C is 12 minus B, which is 4. So 12 squared minus 4 squared. So a squared is equal to 144 minus 16. So a squared is equal to 128. Now take the square root. So a, this is not a perfect square, okay, but I know the square root of 121 is 11, so it's going to be close to that. 128, square root of that is approximately 11.3, and that's measured in feet.